Okay, so our problem is 6.1. We have a truss system. Question is like this. Determine the force in each member of the truss and state if the members are in tension or compression. Set P1 is equal to 7 kilonewtons and P2 is equal to 7 kilonewtons as well. So we have a truss system. It is supported to a ball at point B, and this support restricts its motion in horizontal and vertical direction. And there's another support at point C. This support restricts the motion in horizontal direction. Therefore, we have two support reactions in horizontal and vertical direction at point B, and we have one support reaction at point C, because the support at point B allows rotation. It is pinned there. And we have two external forces, P1 and P2. They are vertical, downwards. Their magnitude is given. It is both are 7 kilonewtons. And we are asked for the members, forces in each member. The truss system is pin jointed at points A, D, C, and B. Now, let's analyze the problem. And in fact, first step is to draw the free body diagram of the truss system in order to find the support reactions. Now again, we have the free body diagram. Here we have P1 and P2, and we have two forces, FBX. Certainly we choose X coordinate as the horizontal coordinate and Y as the vertical one. FBX in the horizontal direction and FBY in the vertical direction. We have FAX in the horizontal direction. Therefore, we need to find three forces. And in fact, this truss system will act like a rigid body. Therefore, we can write two force equilibrium in each direction and the moment equilibrium, which is out of plane. Now, as we see, the most logical choice for the moment is point B, and therefore we can eliminate two forces, and from there we can calculate the FA. So we calculate the moment with respect to point B, and we assume that counterclockwise direction is positive. So P1 multiplied by 2 plus P2 multiplied by 1 plus FAX multiplied by 2, because from A to B it is 2, has to be equal to 0. From here we can easily calculate the FAX. FAX is equal to minus P1 multiplied by 2 plus P1 multiplied by 1 divided by 2. If we substitute the values for P1 and P2, it is 7. 14 plus 7, which makes 21, divided by 2 will give us minus 10.5 kilonewtons. So here the unit is kilonewtons. Okay, so next is to calculate the support reactions at B. Now we find the support reaction at B, and we have another equilibrium equation, which is sum of the forces in in X direction is 0. Now, when we look at the X direction, we have only two forces, FAX and FBX. And from here, we can easily say that FBX is equal to minus FAX. And this gives us 10.5 kilonewtons for the FBX. Now, our second equilibrium equation is sum of the forces in Y direction has to be equal to 0. As we see here, P1 and P2 has an opposite direction with respect to FPY. FPY, we choose it in positive Y direction. And from there, we can easily say that FPY is equal to P1 plus P2. And as a result, it is 14 kilonewtons. Now we have found the support reactions. Now next thing is to number the elements. Of course, we can number the members in different ways, but for the ease, I mean, you don't need to number them, but for the easiness, it's better to give a number. So from A to B, I say that it's the element 1 or member 1, truss member 1. Then from B to C, I say that it is member 2. From D to C, it is 3. From D to B, it is 4. And from A to D, it is 5. So we have 5 truss elements, truss members, and as a result, we have 5 forces to calculate. We can begin from any point, in fact, but let's begin from point A, because in any case, we will solve a set of linear equations. So for the joint A, we have 3 forces at the joint A. If we focus on the joint A, we have P1. We have a force that's coming from member 5, and we have a force that is coming from member 1. As a result, we have this free body diagram for the joint A. We have P1, F5, and F1. What we do is we write the sum of the forces. We write the sum of the forces in each direction. So since it is, this angle is 45 degrees, we can easily say that F1 plus F5 multiplied by cosine 45 is equal to 0. This gives us, this is equation 1. Now the second equation is sum of the forces in y direction has to be equal to 0. This is the second equilibrium condition for the joint. So when we write the forces, we have minus P1 minus F5 multiplied by sine 45, because it's downwards. Remember that we choose the y direction, positive y direction, in upwards direction, and this is equal to 0. From there, we can easily calculate the F5, because this is the only unknown in this equation. F5 can be written as minus P1 divided by sine 45, and from there we can calculate it as minus 9.899 kilonewtons. This will be the value or force that comes to the member 5. Certainly minus sign tells us that it is compressive. Now, since we know the F5, from the first equation, we can calculate the F1. F1 is then minus F5 multiplied by cosine 45. So this gives us the value of 7 kilonewtons for the force in member 1. And positive sign tells us that it is tension. Okay. Now let's focus on the joint B. So joint B is here. Remember that we have two support reactions. We already calculate the force that comes to the member 1. Now we have the force in member 4 and member 2 for joint B. So this is known. Now the unknown force is the force that acts on the member 4 and acts on the member 2. Now let's draw the free body diagram again. Again, we assume that all the forces are tension in the truss members. So F1 is towards the member, F4 is towards the member again, and F2 is towards the member as well. In fact, F4 makes an angle of 45 degrees with the horizon. Again, we have two equilibrium equations. First equilibrium equation is sum of the forces in x direction has to be equal to 0. From there, we write Fbx minus F1 minus F4 multiplied by cosine 45 is equal to 0. When we look at this equation, the only unknown is F4. We already calculated the value of F1 from joint A. So I can find the F4 as Fbx minus F1 divided by cosine 45. Then we substitute the values into their places. So Fbx is 10.5, F1 is 7, and cosine 45 is square root divided by 2. From there, we can calculate the value of F4 as 4.95. Now we have a second equilibrium equation. Certainly at point B, sum of the forces in y direction has to be equal to 0. So when we look at the forces in y direction, we have Fby minus F2 and minus F4 multiplied by sine 45. Therefore, in y direction, we have Fby minus F2 minus F4 multiplied by sine 45, which is equal to 0. Now, in this equation, the only unknown is F2. We already calculated the F4 from x direction equilibrium. Therefore, F2 is equal to Fby minus F4 multiplied by sine 45. So Fby is equal to 14. F4 multiplied by sine 45 is 3.5, and this gives us 10.5 kilonewtons. And certainly, since it is positive, F2 is also tension. Now we find the force that comes to the F4. Now let's focus on the joint C support. So at joint C, we have F2 and F3. We already calculate the value for F2. Fax is already known from the support reactions. So sum of the force in x direction has to be equal to 0. Yes. So sum of the force in x direction is equal to 0. Fax minus F3 cosine 45 is equal to 0. This is what it means in x direction. So from here we can calculate the F3. F3 is Fax divided by cosine 45. This is minus 10.5 divided by cosine 45. And this gives us minus 14.85 kilonewtons. Therefore, F3 is, or the member 3 is under compression with 14.85 kilonewtons of force. And we can easily calculate the F2 from some of the forces in y direction, and that is F2 plus F3 sine 45, and F2 is 10.5 kilonewtons. So as you see, we already found the force in joint B, from joint B, F2 as 10.5. This validates our calculation for the F3 as well. Now, the last one is the joint D. Now we have found the F4 from previous joints and F3 from previous joints, and as a result, the only unknown in this joint is we have already calculated F5 as well from joint A. So we write the sum of the forces in X direction, and we have F4 multiplied by sine 45 plus F3 sine 45 minus F5 sine 45 has to be equal to 0. If we do the calculation, we will see that if we put the values, that is equal to F4 plus F3 minus F5, because all these sine terms will be eliminated, so does not have any contribution. As a result, we have 4.95 minus 14.85 plus 9.9, and this gives us 0, which validates our calculations. And at last, we have sum of the forces in y direction has to be equal to 0. Again, we have F4 multiplied by cosine 45 plus F5 multiplied by cosine 45 minus F3 cosine 45 minus P2. If you put the values into their places, and if we do the calculation, you will find 0, which validates the calculation, our calculations as well.